Hi, and welcome to this GlobalDots podcast. Today, we're going to be talking about API security with CEO and co-founder of Salt Security, Roey Eliyahu. Just a little bit about who we are first. So, hi, my name is Nesh. I'm working for GlobalDots for almost 5 years now, with 17 years in the tech industry. GlobalDots as a company is constantly on the look for new cool vendors that are out there, emerging technologies. And I can honestly say that what Salt Security doing is one of the coolest things that we've seen for a long time, and was genuinely blown away when I saw the technology. And Roy is a font of information on APIs. I can't wait for him to unpack all the cool stuff that he knows. Roy, if you'd like to say hello.
Hey, Nesh, great to be here. Just quickly about myself, I'm Roey Eliyahu, co-founder and CEO for Salt Security. My background is all deep in cybersecurity. I was born and raised in Israel. Before I moved to the States, I spent a number of years in the elite security units of the IDF, the Israeli Defense Forces, where I led and developed cybersecurity systems to defend the military infrastructure against various sort of attack vectors, from network layer attacks to application layer attacks, and saw the growing need for API security already 6 years ago.
Wow, super cool. And I know that most people will be fascinated to know about that history in the IDF. And we know that probably you can't talk about most of it because you're under confidentiality. But is there anything you can tell us from that time? Any lessons learned from that?
Yeah, I think one of the lessons I learned personally is how to, when you build cybersecurity system, you learn how to build them in a way that in the right approach. I think if you look at the market, in cybersecurity market, you have a lot of tools that are built they see a specific threat and they build a tool or a solution just for this specific threat. And cybersecurity is ever evolving space, right? Every month you have a new type of attack. You have lockful shell, stringful shell, a lot of different type of vulnerabilities. And if your approach is not broader, in order to be able to detect 0 days, because you can predict what the next attack will look like. But if fundamentally you have the right approach, you will be able to detect out of the box a lot of attacks, even if you didn't plan specifically for these attacks. So I think it helped me build Salt in a way that we don't need to know all the API threats that still not happened, but the approach will be able to cover for those just because how we tackle this problem, if that makes sense.
Yeah, that makes perfect sense. And actually, it's something that we come up against in the security world, because quite often people, they're obsessed with knowing the flaws. The idea that you put something in that catches a 0-day flaw is often a little bit hard for people to compute, because they live in a world of known attacks, known this, known the other. That's typically how bot protection works. And that's how web application firewalls work and things like that. And it's a new mindset that people need to get their heads around, that actually you will never catch every single attack. So forget about it, and just know that when you do get hit by a new attack, you will know about it. That's what really the new mindset. But it's definitely working with these technologies. That's an uphill struggle to try and convince people of that. Specifically, APIs, we know, have exploded across the marketplace, and definitely in the last 10 years like crazy. But in the last 2-3 years, can you just talk us through the landscape and how that's changed?
There's research just shows that over 83% of the internet traffic is API traffic, which is kind of mind-blowing if you think about the majority of the internet is actually APIs that exchanging data.
Yeah, I wonder what 80 of that 83% is malicious. Probably like 90% of the 83%. But yeah,
definitely a lot of attacks out there. But what happened is that during COVID, that most companies relied on their digital services, right? Because the physical became almost non-relevant, right? You want to order things online, you want to do more things from a functional perspective. Your banking app, you want to go order something from, tickets, manage, like anything they used to go to a physical branch to do. Now they had to give you the option to do it remote. So it developed a lot of remote capabilities, which essentially means a lot of APIs. So there was a huge exponential growth of APIs. Also, the movement to the cloud from data centers created a lot of APIs. The movement to Kubernetes microservices created a lot of APIs because suddenly one system that typically had one API is exposed now has a lot of microservices that has a lot of APIs. So there is a lot of contributing factors to why APIs grew so fast. But also the second thing that happened, more sensitive data of companies, more of their IP was exposed to APIs, right? Because as you become digital, you expose the information of your users, the ability, if you are retail or e-commerce, all the things you want to allow your consumers, your customers to do, you allow it through an API. So if you allow payment transfers, essentially you expose the risk of, stolen money from your company through an API. If you have orders from a retail perspective, you expose that as well. And of course, data, it's a given. So naturally, there are two factors in an equation for attackers that they're looking at. Well, how should I attack a company? And one is how easy it is, right? Every attack vector. And secondarily, what's the price, right? That's kind of the balance. If it's very high price and very easy, that's like an easy equation to, okay, I'll go this route because they want the least resistant path to get to their prize. So what happened with APIs? You have a lot of APIs, so you have a huge attack surface. So it became much easier because companies did not caught up with all of these APIs that they exposed. And on the flip side also, so it became very easy. On the flip side, the prize for an attacker is much bigger. More users signed up to digital services, more data records. So it just drawn a lot of attention to APIs, which we saw in the result of a lot of incidents and vulnerabilities.
Yeah, and it makes perfect sense that if you've got an explosion of APIs and that becomes the main, entry point for all the data, that's definitely going to become the most attacked surface, essentially.
Yeah.
So can we unpack that? Because there is a distinct difference, and I know it from working in the industry, that the way you protect, we've changed over time. So the way you protected a physical infrastructure with a firewall is not the same as how you protect a web application. Hence, we got a web application firewall, and then bots arrived on the scene, and then we needed specifically bot protection. So there's a firewall, then there's a web application firewall, then there's specific bot protection, and now we've got specific API protection. So could you unpack for us, how this became the top attack vector, and what makes it different from existing solutions, basically?
How attacks evolved in the last few years that created the need for a new solution. So we used to have most of the attacks, most of the reason for a lot of incidents and breaches used to be SQL injection, process scripting, and a lot of known attacks, right? That was why the WAF was created originally, to, early in the early 2000s, and went through several evolution steps. But basically, it's mainly for attacks about, and you're looking for specific patterns. What we call one and done attacks, right? There is an API call, there is an injection in it. We'll look for this injection, I'll block it if it's malicious. If it's not, I'll let it through. The problem that what happened with APIs, the attacks have evolved to be much more slow and low. So they're not anymore just one API call or one transaction. That actually can be a sequence of API calls. It's not happening over the course of just, a few seconds or just literally a millisecond, like one transaction. It can happen over days or weeks when you have slow probing of APIs over time. And if you don't see the full context of all these transactions, all these API calls and how they related, it's impossible for a solution to be able to see there is an attack going on, because every one of these API calls in isolation looks completely legitimate. There is no specific pattern like an injection. You can say, hey, that's a known bad. As an example, one of the top API vulnerabilities today called Ebola, broken object level authorization. And it's essentially just the exploit is simply changing one number to a different number. So I can be user ID number 5, this Roy, and you, Nesh, your number 7. I changed 5 to 7. There's not proper authorization check. Boom, I got your details. How do you know 5 to 7 that it's bad, right? You need a lot of context of how normally this works in order to be able to detect it, and to know that it's happening over time, right? So that created the need to a completely different approach to, okay, so how can we solve for these new type of threats that today we cannot do in this narrow view transaction per transaction analysis.
That is the that expression. Could you repeat that expression for me of the switching the number in the account?
Yeah, the enumeration.
Yeah, but you gave the name a specific the attack a specific name.
Yeah, so the number one vulnerability in the OWASP API top 10, it's Ebola, broken object level authorization. In short, it's BOLA, which is the most common API vulnerability out there, probably responsible for the majority of API breaches.
And this one makes perfect sense actually, because the problem that you would see with a company is that actually your API gives a 200 OK response. So essentially it's invisible to you because you haven't broken the API. You've done something that is completely allowed by the API. Yep. And hence you need this something else that's picking up on these attacks.
Yep, exactly that.
So that's a great introduction to API security. I think it's really nice to contextualize this. So I know that API attacks are constantly in the news, and I'm following these on LinkedIn, and I follow the work that you do, and it's super interesting. But is there a particular news story that you could share with us at the minute just to highlight the importance of API security?
Absolutely. Every month there are new vulnerabilities, new breaches that happen because of APIs. We actually have a Salt Labs, which is a completely unit within Salt that their only purpose is to research new vulnerabilities and find new vulnerabilities and educate about the latest and greatest attacks. So one example actually they found, and I'll give you one internal one and maybe one that is a public one in the news. So one that we found was we researched crypto exchanges, which used to be extremely popular, a few months ago. And we just saw that we randomly choose, like I think it was 10 crypto exchanges. And almost within a week, we found, I think in 4 or 5 of them, critical vulnerabilities that allows us as an attacker to exfiltrate or to pull any amount of money actually out of these exchanges. So literally there was a total money of a few dozens of millions of dollars that essentially just through a simple API call or sequence of API call, you can actually take all the money out without anyone needs to click on anything. It's not phishing, nothing of that. Just literally click a script and you have a few dozens of millions of dollars in your bank account.
I would like to say that I'm surprised, but being as though you see a story like that in the news every 6 months, I'm really not surprised. Okay, that's quite astonishing. I'm guessing you can't tell us any of the names involved with that.
Not yet. It probably will be released under our Salt Labs blog post after we did all the responsible disclosure. But after we get the final approval, we will be able to share it. But yes, it's the same vulnerabilities, just the data behind it changed, right? It can be money here, it can be data exfiltrated there. It's essentially the same type of vulnerabilities, business logic vulnerabilities that require a lot of probing and enumeration over time in order to exploit or execute the full attack. Another example, which is a public one, it's T-Mobile, right? One of the largest telco companies, obviously having tens or even hundreds of millions of consumers and customers. They own a lot of data, and a vulnerability being found related to API security posture issue. They essentially had an API without any authentication that you can simply enumerate or give an input, a telephone number of anyone. And in the response of the API, you had what we call excessive data exposure, which essentially you had the name of the person, the last name, their physical address, the last 4 digits of their credit card, the plan, and a lot of details on this specific individual that obviously, it should be only this individual that can be exposed to this information if they're logged in to a certain app. But obviously having explosion of APIs within your environment, everything is being exposed. You have an API is just exposed without any authentication. So you may people may hear it and think, oh, we don't have any API without authentication or proper authentication. Our experience shows that you always have these rogue APIs, these shadow APIs that are being exposed. Nobody know about them. Nobody manage them. Nobody monitor them. And it's enough to have one that exposes this information to get to a breach.
That's super interesting, and it's always amazing to see so many big names in the news all the time. And you'd think that the bigger the company, they would definitely have these problems sewn up by now. Could you just unpack shadow APIs for us? Like, I'm aware of them, but I'm thinking of the audience who's possibly not so familiar with the shadow API.
Absolutely. So essentially, this is the first pillar for API security. There are three main pillars in API security. There is API discovery, there is runtime protection, there's shift left security. I'll talk about them. But the first one is API discovery, because essentially you can't detect or you can protect what you don't know, right? So the first step is really discover all your APIs and understand where is the most critical assets you have. So shadow APIs refers to APIs that are not documented anywhere, are not inventoried. So essentially the cybersecurity team are not aware of them. So obviously they cannot apply any security measures to these APIs. They cannot pen test them. They cannot check if it's meeting the standards. They cannot monitor them for attacks. So obviously the first step is to uncover shadow APIs, so you can start apply security to them.
Yeah, this is super interesting actually, because it's quite alarming, and I've seen this in action before when you actually uncover shadow APIs for companies, and it just shines the light in the dark corner of development that they're blissfully unaware of. So you're something like a world leader of API security, I would say. You wear a nice big API hat, and this has now led you to advise in the OWASP. So more generally, we know businesses have got all these problems and they need some help, and they need some help identifying where they need help, which is where OWASP comes in, and it's where you come in. So could you just unpack a little bit what you're doing with OWASP, and how your work has helped you to define what is the OWASP top 10 for API?
Yeah, so basically when we started, there was no API security category. There was no good knowledge to what is API security, what's needed in API security, what's the latest and greatest attacks. So we felt the world was very, very much outdated in the knowledge. And then immediately we asked the question, where is the knowledge? And one of the most primary sources for application security knowledge is in OWASP. And we noticed there is no OWASP API security top 10, right? Which is so expected to have, given APIs is the major component of application security. So we partnered with OWASP, and they chose us to be one of the leaders for the API security project. And the first initiative within the project was defining the OWASP top 10 threats. This was a process that probably took 12 to 18 months. We collected a lot of data points. A lot of those came from our research and vulnerabilities we've seen in research, as long with the rest of the security community, part of OWASP, that reviewed also the findings. And then finally, in end of 2019, the first version of the OWASP API security top 10 was released. Wow.
And what's the cadence on reviewing that, and what's in the OWASP?
Mm-hmm. Yeah, it's a good question. I think it depends on how many developments happen in the market. We don't want to release something just to release something. But I think currently there is starting to be a little bit of work of kind of revisiting the top 10 and see if there's any modification needed. But it's not a regular cadence of every year or every 2 years. It's really based on developments. Mm-hmm. And I got to say that still the number one vulnerability on this list, by far, is still the number one vulnerability. In the Ebola vulnerability, it's extremely hard to detect and extremely common, and probably responsible for about 40% or above or more of the breaches that are happening in the API security space.
And the effort to fix that, I guess, is absolutely minimal, right? I mean, to fix the problem is a very simple line of code, surely.
So when you know about the vulnerability, it can be an easy fix, you're right. But there is the problem with that you have potentially thousands of tens of thousands of places in your APIs that this vulnerability can exist. So it's basically the reason why it's so common, because it's enough to have one that doesn't have a proper authorization check, and you're exposed. So you can get 99,000 collect, and then you have one exposed. So attackers will simply look for the one that is open, and there is always the one that is open. Always. That's the rule. Probably a few. So track them down, detect it, and know where to look. That's probably the hardest part.
So I want to go back, and because you touched briefly on the three pillars of API security, and from talking to you previously, I know you talk about API discovery, runtime protection, and shift left security, and you would say that these are the three pillars of API security. But can you, we sort of unpacked API discovery with the shadow endpoints, so you can't protect what you don't know about. But could you unpack the other two for us?
Absolutely. So runtime protection is probably the most critical component of all three pillars, because discovery is step number one, as you said, because you can protect what you don't know. But once you discover all these APIs, the next thing you will ask yourself, okay, how can we protect these APIs? I have thousands of APIs running in my environment. APIs are not a new thing, right? You just have more of those today, but you have a lot of APIs already today. It's not like containers that you might say, hey, we'll go first time to production with Docker containers, right? And it's the first thing you will secure. So let's build it more securely. You already have a huge baggage of APIs that your company and the business running based on, or the critical system you have running on these APIs. So you need to have the ability to monitor this API and model the behavior, the normal, legitimate behavior of these APIs, the business logic of these APIs, in order to detect all these slow and low attacks that target the business logic of the API and pinpoint attackers as they're doing the probing and not allowing them to continue to probe your APIs until they find a vulnerability, like some of the examples I mentioned, and then exploit and exfiltrate the data. You want to stop them very early in the reconnaissance process. That typically, by the way, takes few days, can be more or less, depends on your security level, but you want to stop them in the very early attempts, right? Because essentially, if you are not going to do it, they will find a vulnerability. Every API has a vulnerability, regardless of how good is your security. Even Google, that kind of not using open sources, build everything on their own, have the complete zero trust model, also had huge vulnerabilities in several products they have to extract the data for account takeover. So nobody can dodge this type of threat. So you need to acknowledge that. So that's probably the second part. The third part is shift left security. Okay, you are still building a lot of APIs. And this is more strategic, long-term initiative, because here you need to engage developers on vulnerabilities you find in the pre-prod. You want to test for vulnerabilities. You want to look for misconfiguration and gaps, and how to design APIs to be more secured, and analyze what we call swaggers, the open API specs, to know that they are thinking about security while designing the API. But I will say, from a steps and maturity perspective, you want to discover first and protect second, because that will be completely under the security team control. You don't need developers for that. You can do it out of the box, and the value for effort probably will be very high. Shift left security, I think, is very important, but it's not something that will happen overnight. You need to change culturally, the way you interact with developers, they engage and get resources from them to get them to invest in security. You need your maturity level from a CI/CD perspective to be higher. So it's very important you build your future in the right way, but start with reducing the risk you have today.
Great. So thanks for unpacking the three pillars of API security. So it's a nice contextualization for people, particularly with Salt's architecture. What's your unique approach? What makes you different from other vendors in the marketplace?
Yeah, so with us, it's all about context. We are built an architecture that allows us to detect all the latest and greatest API attacks. So what I mean by that, if you think about what I described about the evolution of attacks, the slow and low attacks, that essentially you need to be able to stitch together and correlate potentially hundreds of thousands of data points over the course of days or weeks. You need to have a very scalable architecture that can do this analysis across millions of users in real time, and be able to correlate all of those to determine if there is an attack going on or not. So what we build at Salt is completely different architecture, where other tools relies on more VM-based architecture that inspect every API call in isolation. we are looking at all the user activities that are happening over the course of days and weeks, able to correlate all of them together. And we also are the only company in the world actually that patented ML technology for identifying and preventing API attacks. It's actually public on Google. You can just Google patents, right? API security, will see us. And as you know, Nesh, ML is good as the data it was trained by, right? And because we are the longest in the market and saw the majority or the most APIs and trained our ML models, not only that we have the best ML models in the market that allows to detect much more in a higher accuracy attacks, we also have a scalable architecture, big database architecture that has full context in order to detect these slow and low attacks that if you don't have this context, attacker can just bypass your tool by simply do it just more slowly over time. And if you lose this data, you will not be able to catch them. So that's probably the biggest, differentiator that allow our customers to detect and prevent attacks more than anyone else.
And I can say genuinely, it is awesome. And the phrases ML and get thrown around with almost every product now. Everything's machine learning, everything's artificial intelligence. And I frequently have to tell people when I'm talking about a company that actually is doing ML, I have to say they are really doing ML. It's not because everybody says they're doing it, but you are really doing it.
Yeah, it's very hard to. I'm trying to avoid it, to be honest, because of what you just said. But that's the reality of the matter, and that's the core of our IP. That if you look it up, it was filed already 6 years ago. The patent, even before we started the company, we filed the patent, so it's there, even before the big buzz on the AI.
You were doing ML before it was cool. Generally speaking, the runtime protection part of it, actually, most people tend to be capturing all of the traffic anyway, so they're not actually looking at this traffic. So they already know that they have all the data they need to be looking at, and actually to plug something in just to scrape that on the side is practically zero effort. I mean, when you talk about just getting some discovery in there and looking at some runtime protection, what typically would be a lead time from not having something in there looking at it to having something in there looking at it?
Typically one call. In case of large organization, maybe 2 calls. One call is to scope, hey, how do you want to get it integrated? There are a few options. Second call, you get the relevant individuals and get it up and running. It's not, in our case specifically, right? It varied between, obviously, tools. One of our focus areas was to make it extremely easy to adopt and consume. So how can we get it without any code modification, without being in line? So we are not creating latency issues or performance issues. How can we get it up and running very quickly so you don't need to run any agents on all of the servers? Just making it very easy to plug into existing components in your environment, like containers and load balancers and gateways and cloud environments, and basically automate the deployment so you can get quick coverage for all of your APIs.
Nice. And actually, I have to salute the not inline model, because coming from somebody who looks at lots of different vendor technologies, and we're always talking to people about various ways they can protect their platform. As soon as you talk about inline, you can see the faces of the people shrivel, and it's not a good idea if you don't need to be in line. So you've obviously your wealth of experience from the API industry generally, built a very successful company. You were the first to market. I know you raised $270 million. So you're a market leader in what you do. And, we don't need to do a sales pitch for you for that one. The numbers speak for themselves. But from your professional opinion, what's the future of API protection, and just some other leading industry thoughts about what we can expect?
Yeah, so I believe personally that API security will replace essential application security. And what I mean by that, if you think about it today, there is the umbrella of API security, and under there's the umbrella of application security, and under application security, you have, bot mitigation, you have today at least API protection, you have WAF, you have you have DAS tools, right? You have on the scanning side, you have a lot of things. And the reason why all of them under application security, because applications are the common denominator for all of these categories. But what's happening right now that everything is transitioning to be API based. Application becoming single page applications. You have APIs to APIs from microservices standpoint. You have third-party APIs. You have also a lot of APIs that are not applications, right? You have no code or low code platforms to create and expose APIs. You have serverless. You have integrators, gateways to just integrate and build like just a layer of code, but it's not still application. So API is becoming the bigger common denominator for all of these. So if you think about it, you will need all of these components just for APIs. You need security testing for APIs. You need bot protection for APIs. You need injection and whatever vulnerabilities for APIs. A DLP, right, solution for APIs. So I believe that API security will be the bigger umbrella. It will have multiple categories within API security because that will be the bigger one. And application will be just another example, another use case to how to secure application in addition to many other categories.
Mm-hmm. It's going to be interesting few years to find out. I guess the rate of change means we won't have to wait too long to find out if you're right. Roy, it's super interesting talking to you. Thank you so much for your time. I guess if we wanted to just leave with the one simple takeaway, if somebody's listening to this and then maybe they took on too much information, is there one piece of information that you could give to a CTO or a CISO that is that could help them just on their API security journey as the easiest takeaway?
Yes, there is one. The biggest one I'll provide is the biggest misperception in the market today, that if you have an API gateway, like a MuleSoft or an Apigee or anyone else or Kong, or you have a WAF, that should be enough, because there's some API security wording in it. The reality, they're actually great partners for us. All of our customers, we have API gateways, we have WAF, great tools, but they're simply not built to address all the needs for API security. So that's the biggest misperception. So if you heard everything I said and you thought, oh, I'm good, I have gateway and I have authentication, all of the vulnerabilities, all of the breaches happening to companies with WAFs in place and API gateways, it's just different set of needs that you need to address. And I would highly recommend looking an API security solution. And obviously, I'm happy to talk with any of you to explain why.
That's a great takeaway. Essentially, if you think you're safe, you're not. Sleep well, everyone. Yeah, that's a good takeaway.
That's the reality of cybersecurity. It's evolving. We need to evolve as well.
Absolutely, couldn't agree more. Roy, thank you so much for your time. Thanks very much.
Thank you very much.